All right. So I've got this problem other places on my YouTube, but so many kids are having struggles with it. It's worth solving multiple times and having multiple videos. So we always start by writing the original problem. So t divided by 5 twelfths, my apologies, equals negative 3/10. All right. Now, you dude, so I'm trying not to say names in the video, you dude, I bet this is the sort of problem that's messing with you because these are, like, ridiculous. If you think about inverse operations, we're dividing by 5/12, and you're thinking, let's multiply. But the dangerous thing is, if you just try to use inverse operations, we would multiply with the number that we have, and this starts to get really complicated because we'd have divided by 5/12 times 5/12, and it's just a lot going on. So the first thing we actually do to deal with this is we spot that we have a number divided by a fraction. And anytime we have a number divided by a fraction, that indicates that we should KCF, right? A number divided by a fraction tells us to keep, change, flip. So I'm actually going to bring this in a little bit more so we can see this better. So our t divided by 5/12, we're going to keep, change, flip this. The right side's just going to fall down exactly how it is. So negative 3/10 t divided by turns into multiply because we're going to keep, change, flip. And this fraction, 5/12, becomes 12 over 5. Are we comfortable with how we apply keep, change, flip to turn division into multiplication? And because we switched the operation, we have to flip the fraction. Yeah. Which number? Oh, t is some number. We don't know what it is, but it is a number. They're telling us t's a number. Yeah. So anytime we see a variable, we know it is there to represent a number. Does that make sense? Yeah, so letters in math are actually numbers that we just don't know yet. And that's what we're setting out to solve, is what number is t. So yeah, number divided by fraction, that's because t is a number. Quote unquote, t is a number. And really, it's variable divided by fraction, but that'd be more to write. It was easier to write number divided by fraction. So now that we've done keep, change, flip, and we have multiplication, we think back to that goal of we want 1t. And if t is divided by anything, we also want, not t divided by t, we would want t divided by 1. And if t is going to multiply by anything, we want it to be 1. So if it multiplies by a fraction, it better be the same number over itself so that it turns into that giant 1. Right, so what we need to do up here, and I'm actually going to write this again so that I have some more space. We have t times 12 over 5. To get that fraction to turn into 1, we remember the rule that if we multiply by the reciprocal, we can turn that fraction into 1. So on both sides, we're going to multiply by the reciprocal. Because remember, we can draw that dotted green line if we want to. On the left side, that will now give us t times 12 times 5 is 60 over 5 times 12 is 60. This is good because a number over itself is 1. That is what we want. Equal to negative 3 times 5, negative 15. 10 times 12, 120. Now we got to clean things up. All right, we always got to clean things up at the end. This is 1. If we think back to how CPM would want us to show it, we just draw 1 around it. So t times 1 we can just write as t. T equals. Now negative 15 over 120. If you type this in, Khan will tell you not quite, because we still need to reduce. This fraction can be simplified, which means we divide. Guys, we should be drawing this. If this has at all been challenging for us to do, we should be drawing all of this. We're going to divide by a common factor. So to reduce a fraction, we divide by a common factor. So if those numbers end in 5 and end in 0, what do we know they can divide by? Yeah, when we end in 5 and end in 0, we know that we can divide by 5. So divide by 5, divide by 5. Careful, we have a negative. So negative 15 divided by 5 is going to give us 3. 120 divided by 5, man, break that up. I'm going to make my 120 into 120. So 100 divided by 5 would be 20, but then 20 divided by 5 would be 4 more. Now, if I just did this division, I'd get 24, but I'm not that good at mental math. So 120 divided by 5, I split it up into 100 plus 20, and I divided both of those pieces by 5. We can still reduce, though. We can actually still divide by... What can 3 and 24 still divide by? 3, yeah. And when we divide by 3 on top and bottom, we're going to get a negative 1/8. So we could say, sorry, I don't have much space now. We could say t equals a negative 1/8. To write this out just cleaned up. So again, to review the whole process, what we did was we recognized we have division by a fraction. It actually doesn't matter what comes before it. We just recognize division by a fraction. That tells us keep, change, flip. Because it doesn't matter what we keep, we just keep it. So we kept the t. We changed division to multiplication. We flipped the fraction. Right side carries down. We then decided that to deal with this fraction and turn it into 1, we can multiply by the reciprocal, which is not an inverse operation per se. Like, it really is, but we won't go deep into that. This is remembering that a fraction times its reciprocal gets 1. Right side had carried down, but now we have to do the same math on the right side, so we multiply by 5 over 12. We do the multiplication straight across the top and straight across the bottom to get negative 15 over 120, and that needs reduced. We get a final answer of negative 1/8.